Hello, this is me Vishal and I'm a full stack developer AI building AI integrated products. So today we are gonna be seeing for continuing from our last episode 1. This is episode 2 and we are gonna be seeing how a professional architecture of a real client project is built. Let's start continue from our previous one. So we saw that after the code is committed and all the architecture is built, then the testing is done. Unit test. What's the difference between these tests? Unit test, integration test, end-to-end test. Unit test is basically a part like functions test, login function, register function, payment function, and all the email function, all these small parts of the app, of the means files of a code, small parts, small functions testing. Integration is a full features test. Like login feature is built in our application. User logins and then it goes to backend, from backend to database, and then the data comes to the user, back to user. So this all test, if this all is working, that is called integration test. And end to end is entire flow. Let's again see versus integration test. Let's see if I'm wrong anywhere. I can correct myself. Unit this is basically isolated functions separately, test of functions. This is communication between modules and services. Like if our system is talking to ChatGPT API, so we are gonna see if that's correctly communicating, if they are cooperating correctly, and there's no error. So we make sure. For now, I'm gonna be just talking less and reading, so you guys should also read if you are looking to learn. So yeah, let's read more. This is from the user's perspective, yeah, end-to-end test. Coming in a second. Yes. Back. हेयर स्टाइल तो होती जाएगी यार, खुद ही जिंदगी चेंज, काम पे फोकस। हेलो। टेस्ट वेरीफाइड। एग्जैक्टली। CICD। Like, is this done automatically?
It would be to understand CI/CD early because it changes the way you think about shipping software entirely.
Practices to build, test, and release your code in small, frequent steps. One of the core practices of DevOps is continuous integration, which has developers commit their code to a shared repository, often on a daily basis. Each commit triggers an automated workflow on a CI server that can notify developers of any issues integrating their changes. When a repo evolves in small steps like this, it prevents what's known as merge hell. Imagine Mary, your backend developer, builds a new API for your product. Shortly after, Jane, your front-end developer, starts work on a new UI. A few months later, when it comes time to merge their features, we find that they're completely incompatible, the build fails, and we now have to spend a bunch of time and money resolving these conflicts. Let's go ahead and build a continuous integration pipeline now to see how it prevents issues like this. Here on GitHub, I have a Node.js web app. In order to deliver this app to my customers, I need to run 3 commands: test, build, and deploy. I can automate this entire process in the cloud by using a CI service like GitHub Actions. First, I create
So you want to be a software engineer at Google? Go to algoexpert.io. Pick a question, read the prompt, write some
DevOps, a set of practices to build, test, and release your code in small, frequent steps. One of the DevOps, a set of practices to build, test, and release your code in small, frequent steps. One of the core practices of DevOps is continuous integration, which has developers commit their code to a shared repository, often on a daily basis. Each commit triggers an automated workflow on a CI server that can notify developers of any issues integrating their changes. When a repo evolves in small steps like this, it prevents what's known as merge hell. Imagine Mary, your backend developer, builds a new API for your product. Shortly after, Jane, your front-end developer, starts work on a new UI. A few months later, when it comes time to merge their features, we find that they're completely incompatible, the build fails, and we now have to spend a bunch of time and money resolving these conflicts. Let's go ahead and build a continuous integration pipeline now to see how it prevents issues like this. Here on GitHub, I have a Node.js web app. In order to deliver this app to my customers, I need to run 3 commands: test, build, and deploy. I can automate this entire process in the cloud by using a CI service like GitHub Actions. First, I create a workflow, and then I tell it to run on every push to the master branch. The event triggers a job that runs on a Linux container in the cloud. Then we tell the container what to do as a series of steps. First, it checks out the code in this GitHub repo, then sets up Node.js, installs my dependencies, and runs my test, build, and deploy commands. Now, anytime we commit code to the master branch in this repo, it will run this workflow. If any of the steps fail, the bad software won't be delivered to our customers and will automatically know there's an issue that needs to be addressed. At the end of the day, CI/CD offers 2 main benefits. It helps you automate things that would otherwise have to be done manually by developers. That will increase your velocity, but it also detects small problems early. The bad software won't be delivered
Focus.
to our customers and will automatically know there's an issue that needs to be addressed. At the end of the day, CI/CD offers 2 main benefits. It helps you automate things that would otherwise have to be done manually by developers. That will increase your velocity, but it also detects small problems early before they can grow into major disasters, and that results in higher code quality. This has been CI/CD, or DevOps, in 100 seconds. Make sure to hit the like button if you want to see more short videos like this, and stay tuned tomorrow for a full DevOps project using GitHub Actions.
To unleash the GPT 5.6 family of models onto the public. It comes in 3 sizes, with Starbucks naming conventions,
Okay, let's get back. Uh, CICD, continuous integration and continuous development. Continuous integration means, uh, what I understood, it will automatically be testing our application functions which we are committing one by one and tell us if there are any errors. The server reads your blueprint to mimic your development environment. It downloads your insight function on Node.js. Okay, it does the exact same test. If there are any errors, it just gives it to us. But we have one viewer. Hello viewer, can you write chat if you're seeing? Can you write something in chat? I should put my chat here. Say hello, OSX Live. Are you also interested in learning AI? Today we are learning about project architecture. These so many things. CI/CD. CI/CD is basically when we push code to GitHub, so we can put our guidelines there about how it can test, and it automatically runs the test on our code which we committed, and if there are any errors we get to know live instead. Install packages, what it does automatically. CI/CD installs packages, run test, run linter. What is linter? Viewer is gone. Without CI, integration hell, when everyone writes their code and documents in different separate word files, and after a month they try to put all in one. It is a disaster. True. Huh. It is a disaster. So with CI, what happens? It is like working in a shared Google Doc. Okay, everyone writes in the same place at the same time. The system constantly merges their work and instantly highlights conflicts with that. Okay, we tell the system how to test, run test command and all this, and it automatically runs test commands. This is CI, continuous integration. iPhone app updates without CD, a company finishes building with. The moment an engineer finishes fixing a single button, the automatic delivery system pushes it live to the App Store. Okay. Is there any AI in CI/CD behind the scene, or or does it just run the commands we tell it? How does it know what to do? We have a viewer watching us. You can write in chat, who are you? Traditionally, CI/CD has zero AI behind the scenes. It is 100% determined. Okay, it runs the terminal commands which we tell it. Traditional, how traditional CI/CD works. Doesn't use AI to guess when you are ready. It looks for digital signal. User clicked push code. Okay, we put in the GitHub that whenever user pushes code, run these commands. This is what we are calling CI CD. Test tool. Okay, we are done with phase. Linter is an automated static code analysis tool. Okay, scans your code without executing it to flag program errors, bugs, security when. This is a nice thing, bro. Linter. Linter. First we have CI/CD pipelines, then linter. Let's move forward. Development. Code reaches development, staging, then production. Bug fix. Okay. Checkout crashes. If a customer says checkout crashes, developer will fix the uh, means crash and issue, and then commit it as bugs dash cart crash. Checkout. What does this mean? Explain. Okay, means it is creating a different branch for it. Cart crash, and then fixing the code and then merging. Like this is how code is divided. The versions, yeah. A major change is basically 1 point, then 2 point, like here. Minor change, new backend compatible features. If there are any good features, then the middle one. If there are very minor changes or bug fixes, then these third ones. This is how version number looks like. Professional folder structure. Typical day of a software engineer: pull the latest code, read assigned task, implement a more focused piece of work, commit logic. Uh, commit logic. Uh, okay. The biggest commit logic. Mostly about writing code. Professionals know coding is only part of the job. A large proportion of the work involves understanding requirements, designing maintainable systems, collaborating through Git and code reviews, writing readable, testable code, communicating with teammates, testing and automating developments, maintaining and improving the software over time. This was our professional architecture. Now we should start our editing. This was so knowledgeable. If there's anything extra or extra to add, okay, tell me. We start with our brand project. Tell me, Sumit, I have built many things. This project is gonna be for my portfolio and like a full professional, real and project which is gonna be used by real users. Which can be used by I'll have GitHub repository for it, will create commits, I don't know, branches for different features when needed. Full folder structure. Let's discuss what type of project should I create. We have a viewer watching us, by the way. You can write in chat if you are watching. Who are you? Let's discuss what type of project should I create. I don't know how to pin this. How do I pin this? Are we supposed to do it like this? Let's discuss what type of project should I create. I want to. I will also most probably integrating to pay. I have a idea. A full dashboard or web app. I don't know. Maybe should have many different features, emailing, notifications, SMS, login with Google, login with Google. Okay, let's create a different stream for it. Let's add this one. This was it. Hope you guys enjoyed it. Let's meet in the next one, in which we are going to be starting our project. We are going to decide what type of project I'm going to create exactly, and create a professional requirement document for it. What features will be there, what exactly will it do, and then start our development. We should need